Today we're solving International A-Level Maths paper S1 for the session May 2024. So let's start with question 1. A researcher is investigating the growth of two types of trees, birch and maple. The height to the nearest centimeter. A seedling grows in 1 year is recorded for 35 birch trees and 32 maple trees. The results are summarized in the back-to-back stem and leaf diagram below. So this is the back-to-back stem and leaf diagram. These are the birch and these are the maple trees. So the key 5 to 6 to 3 means 65 centimeters for a birch tree and 63 centimeters for a maple tree. So this is 28, this is 25, this is 50, and this is 50, this is 65, 63, so on and so forth. Find the value of K used in the stem and leaf diagram. So for maple trees, there are 32 trees, and the median is the average of the 16th and 17th value. That's how we will find the median. So what are the 16th and 17th value? So these two rows cover the first 12 values, and then we have, this is the 13th, 14th, 15th, K is the 16th, and 7 is the 17th. So for the 16th, it's basically 40 plus K, right? And for the 17th value, it's 47. This is how we read these diagrams. So we know that the median is 45. So 40 plus K plus 47 over 2 is equal to 45. Multiply both sides by 2 and then subtract 47 and subtract 40, basically normal algebraic manipulation. You would find out that K is equal to 3, right? 2 times 45 is 90 is equal to 40 plus K plus 47. Subtract 47 from both sides and subtract another 40, and that's how we will get K is equal to 3. So for part B, find the lower quartile and the upper quartile of the height grown in 1 year for these birch trees. So to find the lower quartile and upper quartile, we have to basically take this number, which is the number of birch trees, and divide it by 4. And this would give us 8.75, right? So 8.75 is the quarter of all the number of birch trees that we have. So 1, 2, 3, 4, 5, 6, 7, 8, and this is 8.75 right here. So the lower quartile is 39. And for the upper quartile, well, we could count up from backwards. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8 and this is 8.75 because we're counting from backwards. We start from the back, not the front. So it is 57. 39 is Q1 or the lower quartile. 57 is Q3, which is the upper quartile. So the researcher defines an outlier as an observation that is greater than 1.5 multiplied by the interquartile range, which is Q3 minus Q1, plus Q3, or less than that same range subtracted from Q1. Show that there is only one outlier amongst the birch trees. So firstly, let's find out the value for which we have an outlier which is greater than this number, and then we find out this number to find out the outliers on the lower end, and then we can find out the outlier that we're searching for. So we have the Q3 and Q1, so let's just substitute all these numbers in. All right, so Q3, right? Q3 is 57 plus 1.5 multiplied by Q3 minus Q1, right? And this number is basically 84. So any number that's greater than 84 is considered an outlier. And we have a number which is 85. So this number is considered an outlier, right? So our outlier is 85. Well, and we know that this is everything we need because we know that there is only one outlier. To identify if there were any outliers on the lower end, we would have to find out this range, which is 39 minus 1.5 multiplied by the interquartile range. And this number, well, this entire expression would evaluate to 12, right? We do not have any number less than 12 over here. The lowest number is 28. Therefore, there are no outliers on the lower end of the spectrum. The grid on page 3 shows a box plot for the heights that the maple trees grows in 1 year. On the same grid, draw a box plot for the heights that the birch trees grows in 1 year. So we start from the lowest reading, which we identified as 28. So over here. And then we keep on going till we reach Q1, which we know is 39. So till we reach here. And now we start our box. So we open it, right? And we search for our Q3, which is 57. And we keep on drawing until we reach 57, right? And then we close it. Our median, right, for birch trees is 48, right? So we go over here and draw in for 48, right? A median, for example, if we have 35, so if we divide 35 over 2, then it's the 17th.5 term. And then we search for the highest term that is not an outlier, which is over here. It appears to be 76, right? So we go over here and we go to 76 and connect them. And then we have one outlier, which is the 85, and that we draw it as an X. And that's how we draw a box plot. Comment on any difference in the distributions of the growth of these birch trees and the growth of these maple trees. State the values of any statistics you have used to support your comment. Well, firstly, we could spot the median. The median for the birch trees is greater than the median for the maple trees. And from that statistics alone, we could find out that birch trees on average grow taller than maple trees.